Hello and welcome. In this tutorial, we will learn what is called data imbalance. We will first understand what data imbalance is, then we will see how machine learning models fail when your data is imbalanced. After that, we will see the best ways to deal with data imbalance. So let's get started. Alright, so let's first understand what data imbalance is. Then we see some of the techniques that we can use to deal with this data imbalance. Now, when you're dealing with supervised machine learning problems, normally you have a target class that you want to predict whether a customer will pay a loan or not, or whether a student will pass an examination or not, right? So you have certain targets that you want to achieve by the end of, the building the model. You want to predict whether that target, you want to be able to predict that target. Okay, so if you take, for instance, whether a customer will purchase a loan or not, you have a target class that you already want to build a model that match that class. All right, now what normally happens is that in the real world you have this target class, and then you realize that most of the people that apply for the loan pays the loan, right? And very few of them don't pay the loan. Now, if you have that kind of a situation and you're building a model to predict whether a customer or whether a new customer will pay the loan or not, in that case, your model is going to learn from that data where most of the people have paid the loan and very few of the people have not paid the loan. And in that case, your model is going to predict mostly that a lot of, the new customers are going to pay the loan. But you don't really know whether that new customer will be one of those few people that don't pay the loan. Okay, so that's actually what happens. So let's actually take an example. If you want to predict, right? You want to build a model to predict, right? You want to, in this case, you want to predict whether a customer, right? Whether a customer will pay back a loan, right, or not. Now, in this case, let's say that you already have a data set, and then in the data set you have customers who pay the loan, right? So those who pay the loan, maybe you have about, so I'm talking of the class, right, which is a target class. So those who pay the loan will be maybe about 500 of them, okay? And then those who do not pay the loan, so let me write that, do not pay. Okay, do not pay. So those who do not pay will be, let's say maybe 50 of them. Okay, 20 of them is fine. Now, in this case, if you're going to feed this data to a machine learning algorithm to build a model, what happens is that your machine learning algorithm is going to actually memorize this, right, at the end of the day to give you the model. And then when you deploy this in the real world, what is going to happen is that any new customer that is going to come in, since your model knows that most of the people pay the loan, is going to predict that the new customer is going to pay the loan. But that's actually not the case, right? That's not the case. Maybe the new customer will be one of these, right, and not one of that, right? So you want to actually build a model that can actually effectively predict whether that new customer will pay the loan back or not. Okay, you want to have that kind of a robust model, or a model that can generalize and not a model that is kind of a bias. Okay, so that's actually what we refer to as data imbalance. Okay, so what we are saying over here is that we will have a situation where the classes, right, that is the classes that you're going to predict, which is your target, right, whether a person will pay the loan or not. In that case, you have a situation where these classes are not represented equally, right? That is, some will be higher than others, right? Some will be higher than others, and in that case, your model is going to be biased in that case. All right, and this is actually a real world situation where you're going to face it over and over again, right? It's a real world situation that you're going to face over and over again. For instance, if you take the banking sector, for instance, right, there's a lot of cases where some of the transactions will be fraudulent transactions, but most of the cases the transactions are normal transactions. That is normal transactions with no fraudulent over there. There are a few of them that are fraudulent, but irrespective of the fact that few of them are fraud, right, and most of them are not fraud, you still want to capture the few that are fraud, because those small ones that are fraud can actually make the bank incur a lot of costs. So you want to have a model that can figure these small ones out, right? You want to have that kind of a model. On the real world, the transactions that are not fraud will outweigh the ones that are fraud, because most of the transactions are normal. So you can have a transaction where about maybe 5,000 transactions, and then maybe about 2 or 3 of them will be fraudulent, right? So about 4,998 will be normal transactions. So in that case, your model will actually find it difficult to figure the small one out. Okay, so let's see what happens when you have such kind of a data set and how you go about it, and even how machine learning algorithms fail to build a robust model when you have such kind of a data imbalance. So what I'm going to do over here is that I'm going to actually use this credit card fraud detection data set, right, which will actually help us to understand this concept of imbalanced data, right? So let's load this data set, and then we can walk through step by step. Okay. So over here, I'm going to import the necessary libraries that we're going to use in demonstrating this concept. All right, so we were going to load our data set into a pandas data frame, right? So we're going to need pandas, and then we will actually use NumPy to perform all the manipulations that we're going to perform on this data frame that we're going to load, right? We're also going to do some visualization, so we will need Matplotlib and Seaborn for that. All right, and then sometimes there will be some warnings if you're using some libraries that there's an upgrade that you've not upgraded yet. It will just be giving you some warnings to upgrade them, right? So I'm just getting rid of that so that we can concentrate on what we are here to learn. All right, now that we have our libraries, we can now load our data set. Okay, you can now load our data set. So as I said, this is a credit card data set that I have, and I've also given it to you on the resource session, right? So if you are using you can just download it from the resource session, and then you can work along with me. Okay, so now that we have our data set loaded, and then we've stored it in a variable called df, all right, then over here we're going to see just the first 5 rows, that is the head of it, right? So if we do that, this is a data set that we have, right? So we have from time, we have time or v1, v2, v3, v4, all the way to v28 amount, and then the class. Now this v1, v2, v3, they are actually transactions of real people, and since we're using this data set, we need to hide the identity. We don't need to put the information over there. So we use principal component analysis, that is PCA, to actually extract these data from the real ones, so that we'll be having these components instead of the real components, the real data that we have with regards to the transaction, right? So that's why you see v1 all the way to v28, right? Then we have the amount, that is the amount of the transaction that went on, right? So some $149.62, some $2.69, and then we have the class, which is our concern over here, right? And this class contains 0 and 1, right? So 0 means that the transaction was not fraudulent, whilst 1 means that the transaction is fraudulent. So if we see any 0 in here, it's a normal transaction, right? If we encounter any 1, we see that that 1 is actually a fraudulent transaction. Okay, and we are seeing just the first 5, so that's why you're just going to see, you are not seeing 1 over here. So there are 1 in there, but there are few. Okay, so let's actually see how many 1s and how many 0s are there, right? So we're going to do this. We're going to pick the class column. So in our data set, we pick the class, right? That is, if we go to our data set, which is the df, right, which is the df, we pick the class, and then we see how many counts, unique counts are there. So we use the value count to do that. All right, now over here you can see that we have 23,000, right? 23,235, right? Of the transactions that are normal transactions, right? Then we have you have around 87 of them that are fraudulent. So now you can see the ratio over here. You can see the ratio over here, right? Huge difference. Right, huge difference. The number of normal transactions are a lot, right? They are huge. That is 23,235 as against the fraudulent ones that are only 87. Right, so you can actually see that there's actually a huge difference in this distribution with regards to fraudulent and not fraudulent transactions. Okay, so that's why we say that the data is imbalanced, right? Because if you compare the two, it's not balanced, right? One is outweighing the other. The normal transactions are outweighing the fraudulent transactions. Okay, so we say that the data is imbalanced. All right, now that we know our data and we know that we have this problem, let's actually see some of the things that we can actually do with regards to this fraudulent case. Now, what I'm going to do over here is that I'm going to use a pie chart for us to visually see this imbalance data in imbalance class in our data set. Okay, I'm going to use a pie chart over here. So let me actually show you the pie chart so that we can actually see what we are expecting. Okay, so this is actually the pie chart. Now let me walk you through the code over here. What I'm going to do is that I'm going to create a fraud variable here, and that is going to contain the number of fraudulent cases, right? So I'm saying that I'm going to count the length of the fraudulent cases. That is where the class is equal to 1, right? So where the class is equal to 1 is 87, right? So what I'm saying that fraud is equal to 87. That's basically what I'm doing over here. Okay, fraud is equal to 87. So it's just equal to the length of the number of cases that are actually equal to 1, which is fraudulent case, and then the not fraud, which is the one that is equal to 0, right? So if I pick any of the equal to zeros, I count them using the length function, right? So in this case, it's just going to be equal to this number over here, right? It's just going to be equal to this number over here. So that's basically what is happening over here. Okay, so now that we know this part, now what I'm going to do is that I'm going to create a labels, right? So I'm going to create a label of fraud and then the not fraud. So that's basically what you can see over here, right? Fraud and then the not fraud. Okay, so that's the labels that I'm creating. Then after that, I'm going to say that, okay, the size of each of the sessions in the pie chart should be the same thing as the values that we have here. So fraud is equal to 87, right? So this fraud part, the size of that session will be equal to 87, and then the not fraud part, which is this part, right, will be the size of this one, which is going to be this one, 23,235. Okay, so now I'm going to now plot it over here using this. So if you see over here, what I'm saying that I'm going to set the size of this pie chart, right? So the size of this pie chart is what I am setting over here. So 10 and then 8. 10 will actually be this part, right? So this part will be the 10, and then this part will be the 8, and then this part will be the 10. Okay, so that's basically the 8 and 10 that you see over there. You can just change these values as per your requirements, right? Then the pie chart, we have a pie chart in Matplotlib, right? So I'm using plt.pie chart. So plt is nothing but the Matplotlib library, right? So we imported matplotlib.pyplot as plt. We just shorten matplotlib to plt. So you can just shorten it to maybe mat or maybe plotlib or something like that, whatever you want, right? In this case, I'm just giving it as plt, right? Normally you will see this plt mostly in everywhere, right? It's just a short form of matplotlib.pyplot. All right, so I'm using that pie chart function, which is present in Matplotlib, and then the size is going to be the size that I've given over here, which is 87 and 23,000. 87 and 23,234. Okay, and then the labels are going to be the labels that I've created over here, which is the fraud and not fraud. And then over here I'm using this, I'm saying that whatever numbers that are going to appear, I just want it to be in one decimal place, right? So that's why you see 99.6%, but not 90. There's going to be a lot of decimal points here, but I just want to cut off the decimal point. I don't want a lot of decimal points here. It's going to be like maybe 99.607 for a lot of decimal points in there, right? I don't want them. Or maybe 0.4 5 7 something, a lot of them, blah blah blah. I don't want all of that, so I just cut it so that I get just one decimal point over there. And then I'm saying shadow equals true, right? That's why you see some shadows over here, right? What else? Starting angle because 0 is just this part, right? Just started. You can make it 45 or 90 degrees. Each one. I mean, either of them work. And then I have the title over here, right? Ratio of fraud versus not fraud. That's what you see over here. Okay. And the font size and blah blah blah. All of these are something you can just change your, according to your own preferences. Okay. So after that is done, now if we see the pie chart that we have, you can actually see that we have a whole 99%, right? A whole 99.6% to be not fraud cases, whilst only 0.4% is fraudulent case. Okay. Now in this case, if you're going to build the machine learning model on this one, your machine learning model will know that okay, at best, what I can do is that I'll predict everything to be not fraud cases, right? Because this one is quite insignificant, right? Meanwhile, this is actually our concern, because if this small one that you can see here can actually collapse the financial institute, okay, this small fraudulent cases can actually collapse the financial institute, can give them a lot of financial burden over there, okay, a lot of financial problems. So we want to figure this thing out, right? This small thing out. So let's see how we can go about this. Right now, if we don't treat this and then we try to even build a machine learning model on this, what will be the results, right? So let's actually see that. Okay, now I'm just going to see if there are any null values in there. In fact, there's a whole session on how to deal with null values or missing values. All right, so we don't need to worry ourselves about that. In this case, I will just drop them because that's not our main concern in this tutorial. Our main concern here is to deal with data imbalance, but there's a whole session on how to deal with missing values or null values, which we're going to go into details, right? So let's actually concentrate on what we are here for. Now, if I check if there are any null values in there, I can actually see that we have some columns that are not having null values in there. That is from time all the way to V22, right? There are no values, null values in there or missing values in there. But from 23 all the way to class, we see that there are some missing values in there. Okay, so we're going to actually, in this case, we're just going to drop them, right? Dropping the null values should be actually the last option to do, right? When you get to the missing, how to deal with the missing values, or when you watch that lesson, you're actually going to understand how to properly deal with missing values. Okay, so in this case, I'm just going to drop it since it's not our major concern here. Then if we check again if there are null values in there, now you can see that they are all false, showing that there are no null values in there. All right, we're going to use this dummy classifier, right? We're going to use this dummy classifier to build a machine learning model on the data set that is imbalanced, right? We're going to feed the whole imbalance data set to a machine learning algorithm to see if we can build a model that will actually help us to make a good prediction in the real world. All right, so let's actually see that and see the results. Now, what I'm going to do over here is that I need to actually separate my data set into dependent and then independent. That is separate the target from the predictors. Okay, so if I show you the data set, let's actually go back to our data set. Okay, so in this case, what we actually want to do is that we want to use all these variables that we have, right, from V1 or from time all the way to all the way to amount, right? We want to use all these variables to be able to predict this class. Okay, to be able to predict this class. So now what I'm going to do is that I'm going to separate the two. Okay, every data points all the way from time all the way to amount, right, is going to be in a variable called x, right? And then only this one, right, only the class, right, only the class variable or the class column is going to be represented as y. Okay, so that's basically what we are doing down here, right? So let's go the way down there and see what we're doing. Okay, so you see that we are selecting only the class, and then we see that is for y, and then when we drop only the class, the rest is for x, right? We could have also selected them individually, but we can just drop the class and then the remaining, right? We can just drop the class and then the remaining of the data set will be for x. Okay, and then we are specifying that axis equals 1 so that we actually tell Python that what we are dropping is actually in the column, right? So if you use axis equals 0, you are saying that Python should look into the rows, but in this case what we want to drop is in the column. So we say axis equals 1. Okay, so 1 for column, 0 for rows. All right, now let's now build this dummy classifier, right? So that we actually get to know what happens when you feed your your data set that is having imbalance class to a machine learning algorithm. Okay, so what I'm going to do is that I'm going to split this data set where I'll use some of the data set to build the model, then I'll use some of the data set to test the model. Okay, so I'm going to use this train test function, which is present in model selection, which is part of sklearn. Okay, and then I'm going to use this dummy classifier to also do the build the model. All right, so that's a machine learning algorithm that I'm going to use over here, and then after that I'm going to check some metrics, right, which includes the accuracy, the F1 score. We will see these ones later on, right? We see these ones later on. All right, now let's actually split the data, right, into the training and then the test over here. All right, so normally what we do is that we need to divide our data set into two. That is part of it for training and then part of it for testing, right? So in this case, I'm going to use 25% of the data set for testing. So that's why I see test size over here to be 25. Then I use the rest of the 75 for training, right? So I'm going to use the rest of the 75% for training. And I pass in my data, which is the X and then the Y that we defined earlier on, right? Then I use the train test function. So now what is going to happen is that I'm going to divide this X and then the Y, right, into this number of variables over here. Okay, so part of the X that I will use for training will be stored in the X train, right? And then part of the X that I will use for testing will be stored in the X test. Okay, and then part of the Y that I will use for training will go into the X train, and then part of the Y that I will use for testing will go into the Y test. And this is actually going to be done randomly, right? So that's why I set random state equals 50. This value can be any value at all, right? What you need to do is to just set random state, because if I run this notebook for the first time, it's going to generate random values for these variables that I'm creating over here, right? And if I run the notebook again, right, it's going to generate another random, different random values to be associated with these, right? So in order to get the same random values that you generate for the first time, you can just set the random state equals something, right? Equals any value at all. It could be 1, 2, 3, whatever value that you want. Okay, so that you just get the same random values over and over again. All right, when you run your notebook, because you don't want to deploy a model that will be having randomly associated data points, right? You just want a consistency in that. All right, so now that is done, the next thing that we're going to do is that we're going to use the machine learning algorithm here, which is the dummy classifier. Okay, and then I'm saying that the strategy here is just going to be the most frequent. We're going to see more of this in the machine learning class. What we want to demonstrate over here is how the machine learning algorithms or the model will actually perform when you feed your data that is having imbalance class. Okay, then what I'm going to do is that I'm going to train the model, right? So when I initialize this machine learning algorithm, I store it in a variable called dummy C, just dummy classifier. Okay, just a variable name. You can just name it the way you want. All right, then I'm going to use that. You can even name it as model, right? You can just name it as model, right? Then I use that dummy C to just fit, right, just the model over here. So maybe I could have done something like this. Okay, I could have done something like this. Could have written here model. Okay, then I use over here, I use the same model over here. Then I do model.fit, right? So it's nothing but you're just making let me actually change this one too, right? So what I'm doing over here is that it's nothing but just making your model learn, right? So fit here means that you are making it learn, right? To learn from the training data, right? Which is the X train and the Y train that we actually created over here, right? Remember, we're going to use the S test and the Y test for testing. Okay. Then after that, I'm just going to make predictions, right? So that I'll be able to see if my model will be able to predict correctly what I want it to predict, right? So if if we have a new data set, which is the X test, which our model has not seen before, which will going to represent what the real world data is going to be like. Okay, so would it be able to predict a fraud case as a fraud and not fraud case as not fraud, right? So that's what I'm going to do over here. Then after I do that, I store the predictions in what is called dummy predict. Okay, so let's actually see the accuracy of that. Let's actually going to measure. Let's actually measure the accuracy and see how our model is doing, whether it's correctly, it has correctly, learned from the training data, and it will be correctly able to predict the test data in the future. Okay, so let's actually see what is going to happen over here. So I'm going to see the unique numbers that the unique variables that my model is predicting. Then I also check the accuracy of the prediction. Okay, that is the testing data and then the prediction, right? How well is let's say, so if we have 0 in here, it's the predictions here. This is the prediction that we have. So if we have 0 in our test data, which represent the real world scenario, right, would our model be able to predict the same 0, right? Or it's going to make a mistake by predicting 1? Or in the other case, if we have 1 here, is our model able to predict 1 as well, or is going to make a mistake by predicting 0? So that's what I'm going to compare, and then check how accurate it is using the accuracy score. All right, so now let's actually see something over here. So now if we do that, we can see that it's actually predicting zeros, right? It's most of the times predicting zeros. It's actually making 99.6% over here, which is more like almost 100%. It's actually making 100% prediction, which is quite very good, right? When it comes to, if you are just seeing the score over here, it's actually very good. If you have a model which is making 99.6, which is almost 100%, it's actually a very good one, right? However, the caveat here is that it's just predicting 1 class, that is 0. It's not predicting any 1 there. It has overlooked the 1. You see what we are talking about over here, because the distribution of the 1, or the quantity of 1, is very small in our data set. It's not actually even giving attention to it. It's just predicting zeros, right? So it doesn't matter what values that comes in or what data points that comes, it's just going to predict 0, right? It's just going to say that the transaction is not fraud. So it doesn't matter the activity that is going on, whether the activity is fraudulent case or it's not fraudulent. The model is just going to predict that the activity is not fraudulent. That's what is going to happen over here, which is a very bad thing to actually do, right? So if you are just seeing the accuracy here, you'll be thinking that, oh, you're doing very well, you've done well, you built a very beautiful model which is very robust, is working. But actually it's just it has just memorized 1 class, and it's just saying that, okay, this is the best scenario to do, just predict 0, and that's it, and I'm done. Right? Because the model is also lazy, it doesn't want to do a lot of work. Now that you've given it opportunity to just see the majority class and predict that, it's just going to do that. All right, and that's not what we actually want to do. Okay, now that is dummy classifier. Let's also use a different algorithm, right, like the logistic regression, and then see how the results will be. Okay, so what I'm going to do over here is that I'm going to import the logistic regression, which is part of the linear model in sklearn. Okay, so if I do that, the same thing, I just initialize it over here. All right, so logistic over here. Then what I'm going to do is that I just use solver equals label linear. As I said, these are hyperparameters, right? So these are things that you see in the machine learning class. Don't worry about this thing. You can just check the machine learning course, and then you see more of these things in there. Okay, if you're in the data science and machine learning projects and deployment mastery, you will see more of these things over there. All right, then I initialize it to logistic over here. In this class, our main concern is to demonstrate imbalance data, and then we will see how we do with this. Okay, then I make it learn over here, logistic.fit, learn it from the S train and then the Y train. Okay, now let's see the output of this one over here, and then see normally when you run, it's just going to show you all the hyperparameters that you have over here, right? This is not something you should even bother yourself about. All right, now what we have over here, we're going to check the predictions, right? We're going to make some predictions over here, and then we store it in a variable called logistic pred, and then we check the accuracy of that, just like we did for the dummy classifier. Okay, just like we did for this one, right? So the same format that we're using over here. Now you can see that this one too is making 99.5%, which is quite good. However, it's just the same thing. It has also memorized and predicting only zeros in there, right? It's just predicting only zeros in there, but it's not generalizing. It's not actually able to figure out the small fraudulent cases, right? Even if the fraudulent cases are small, we still want to figure those out, because that's our major concern here. But if you are not able to figure that one out, then there's not even any need to build a machine learning model, isn't it? All right, so now let's now see how we're going to actually deal with this data imbalance before we build the machine learning models. Okay, let's see how we actually going to deal with this and some of the useful techniques that we can actually use when dealing with data imbalance. All right.